cloud. All right, the all-rage and mighty cloud. Every time, Red Hat, we had the Red Hat Summit a couple of weeks ago, and the joke of the company was if you put cloud in the name of your presentations, you were going to be allowed to present. So the idea here is, when I go off to the cloud, if I go off to EC2 or any one of the cloud providers, I don't have to do number one, which is break into the web server, and I don't have to do number two, which is get a root escalation. With these guys, for $19 a month or whatever it is, I get root. Now all I need to know is about a hypervisor vulnerability. So if I'm a hacker, for a cheap amount of money, I can sit out there all day long waiting for, as Pepsi, waiting for Coca-Cola to show up, and I can finally get the secret recipe. For some reason, the lawyers at Red Hat don't like when I show this. I'm not sure why. A last slide. One of the secret sauces of, if you've dealt with SELinux at all, you might have heard a thing called MCS labeling. When MCS labeling, SELinux field is made up of 4 fields. The field we usually talk about is the type enforcement field, which is the 3rd field. The 4th field is the MLS field. When we run it in a targeting system, we call it MCS, multi-category security. And we really never found a use for it until now. So the secret sauce of SELinux, of this secure virtualization, ordinarily SELinux is all about the type. So if I said this is a type of a secure virtualization client, I'd say that the image is a secure virtualization image. Well, 2 types. If I say S for a T can talk to S for an image T, then the first virtual machine, when it broke out, could actually attack the second one. But we took the last field, and we added basically a randomness. So we're not actually using categories for anything important. We just use a random MCS label. The library ensures that that MCS label is never reused. So that it ensures that 2 virtual machines running will have the MCS field as well as the type enforcement field, and that guarantees us the separation, even though they're all labeled with the same type. I'll let you read for a minute. Okay. The idea of this slide is that, if we could just get, the computers could just get rid of us humans, they'd be a lot more secure. Well, in RHEL 5, targeted policy ran all users as unconfined T. Unconfined T is the goal of the unconfined T label is to allow a user to do everything he could do if SELinux was disabled. And that's sort of how we want the default user of the system to be, because if SELinux is blowing up as soon as you log onto the box, you're going to get real sick real fast, and you're going to turn it off. So out of the box, we wanted to run unconfined T. In RHEL 5, we actually had a separate policy, the MLS policy, and another policy called strict policy. And some people thought strict policy was more strict than targeted policy. But the main difference between targeted policy and strict policy in RHEL 5 was whether or not we had confined users. And pretty much everything in system space is exactly the same. So in RHEL 5, we actually did a real good job of confining soldiers. Right? The only people that use MLS policy are people in the Department of Defense. So they had the capabilities for confining users, but as I said, we wanted to default all users in the targeted policy in RHEL 5 to be unconfined users. But the problem with this, these are the new confined users that are available inside of RHEL 6. When we came out with strict policy and MLS policy, originally there were 2 confined users defined. There was the user T and the staff T. But a user T was all users that don't administer a machine, and staff T was users who administer a machine. That's really the only difference between the 2 domains, or types. And so what happened when we first came out, just years ago, when we first came out and there was no unconfined T, these policies kept on growing. They kept on getting more and more powerful. So pretty much they got to the point where you could run your entire desktop section with either one of the types. But when the military type people wanted to write policy, they usually wanted a confined user as more confined than either user T or staff T. They wanted to do a thing where they have a terminal user log onto a box, not be able to do anything in the home directory except to potentially read one directory of the system. So when they come to me, they'd ask me, how do I write policy for that? And I would say, I don't know. SAFT and we get user T. They're both real powerful. So some people would come in and try to hack it out, and other people come in and try to create it from nothing. And they usually be broken. So what I did is I looked at the ultimate, the least possible privilege confined user, and that's when I created guest T. Now when I created guest T, I realized that I have two machines at Red Hat that I use all the time that I could use with a guest T policy. A guest T policy is a user that is no SELinux, you can't run any administration, can't run X. Basically only can be reached by the local login or an SSH account. Can't compile it, can't execute anything in its home directory, really can't compile anything in its home directory. But basically can come in, back to the network, and transmit mail from it. So can you people think of where you would have that type of account? Well, if you've ever gone and downloaded any of my stuff at people.fedoraproject.com or people.redhat.com, those are sites that I can just SSH into. And I update the public HTML directory and put my content on it. Now, the administrators of that machine really don't want me going there and sending mail. They don't want me trying to hack the system by running students.